why is everybody here? I think we originally said open source economy, practical, strategic, collaboration, all this connecting stuff, connecting the dots. What are all the groups that we can learn from? How can we collaborate? So I'd like to focus this discussion on that, particularly perhaps like who are some of the key players that we need to be talking to and working together on the open source economy, because there's so much. I mean, it's hard to keep track of it all, and I'm sure with all the people here, with all the different insights, there's a lot of connections that can be made. So I'm going to sit back and I'd say first, maybe we can go around and just briefly go through everybody what are the particular focuses of each person here. I'm interested in the open source economy in general. That means a productive mechanism where people truly collaborate, as I talked in my discussion today. When can we learn to get along and cooperate and economically? How do we develop products in an open way where imagine companies would go to a repository or a collaborative pool. Imagine some kind of a mechanism where people can actually be encouraged, companies are encouraged to work together instead of having each their own proprietary research and development departments. We can stop reinventing the wheel. There's many pressing world issues we can take care of. We can accelerate innovation to solve problems faster than they arise. So that's my general interest. I'd like to make practical routes as far as contacts for doing that. As far as our on-the-ground activity back at Factory Farm, we are developing, I guess, if you can point to a single product, it would be the OSE, the Open Source Ecology Microfactory. So think about a 4,000 square foot fabrication facility like you saw in my presentation, where you can produce just about anything. And the plans are constantly evolving. People are contributing from all over the world on it. And starting with the 50 tools of the Global Village construction set. But we predict that we can pull in like $80,000 per month from this 4,000 square foot facility. And we have good evidence that we can do this $5,000 per day kind of production model, which literally is more efficient than standard industrial production. So there's huge potential there. That's kind of what I'm working on full time. Let's start with getting right into, because when we talk about all this stuff, it has to be, like the way we changed, our change model is that we're actually changing the economy, and that means production, productivity. Absolutely efficient production. I mean, everyone talks about that, like capitalism, communism, Marxism, it's like all about efficiency. Well, here we add the extra effort, and that is actually distributing the wealth truly. That means opening up through transparency. So there's a significant difference, but you have to have the product. So what is the product, and how do we get there? So let's be very specific on the production plan. So we've done, just to recap that. So we've got a 4,000 square foot fabrication facility. And just to recap a little more of what for those of you who missed the speech, basically I took a raw parcel of land. After finishing up my PhD in fusion physics, I felt absolutely useless and started to get into a piece of land to see what can be done as far as building a real community, sustainable technologies and all of that. And the first thing I found out is that you need equipment. There's a serious gap because all the stuff that's out there is either expensive or it's designed in a way that it breaks. And that was the classical story with the tractor. It broke, I paid to get it repaired, then it broke again. Pretty soon I was broke too. That kind of story, that is real. And that prevents anyone from even attempting a lot of times this kind of operation. There's a lot of knowledge, so many different areas of knowledge that you have to have. So we're basically trying to open source that entire set of knowledge. We call it the Global Village Construction Set of open source blueprints that literally allow you to build an entire economy, which means the radical claim, a single shipping container of all these tools can be plopped anywhere, even in the absence of an industrial economy. But in a place where you actually have rocks, sunlight, plants, soil, water, the basic resources. And from there we can bootstrap to agriculture, to production, to everything, such that you can really deliver a modern standard of living from those local resources at 2 hours per day. That's crazy, and I look forward to it. All the stuff that I've seen so far with our work, I think it's possible. And I mean, I don't have the authority to claim that, like, oh yeah, it's going to happen. I will show you guys. So that's the, I mean, I can't, it's really hard to grab one's head around these concepts until you do it. So I don't need to really try to push that on you guys. It's about showing it bit by bit. So what did we show so far? We did show that the brick press, I mean, the first prototype I built, maybe like 2008, took a couple of months of development to go through design and all of that. And then we learned. So we talked to the best people out there. I actually talked to the guy who invented, not invented, but designed the leading machine on the market. And he was like, okay, I'm calling you up. Hey, tell me about this. And he was like, what are you doing? I'm saying, I got this open source project. I want to make a better world. And he was really willing to help. That was a lot of times you get this very positive energy from people that it's like, wow, these guys are doing something worthwhile. I picked his brain in a few hours, got some of the critical design elements, and was able to produce the machine after a couple of months of time. So then after that, we get better and better at it. We built a few machines last year. And this year we had 8 people. There was 6 people. 6 people and a videographer. You can look at our blog. We have the full videos of this and all that. opensourceecology.org. You can access all of our blog, wiki, and all that. 4 days, 6 people, 1 videographer. A couple of people were skilled fabricators. All of the other people were pretty much volunteers and new people. So we're showing the model where if you have a perfect set of plans, because we put a lot of time into doing this whole layout. Here's how you build all the pieces, literally a whole tree of the build out. So you've got this, we call it a fabrication diagram. So you list all the different components when they're kind of parallel on the page, on the same level. You see, okay, well, you can do all this stuff at one time. So you can allocate people. Okay, a person can do this, 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 that, so you can distribute it to the whole team. Then you see subsequent steps that rely on the former steps being completed, but everywhere we planned out who does what at what time and what parts they do. We had the full set of fabrication drawings and just well prepared and knocked it off in 4 days. And that was good. So right now we source it off the shelf. I mean, we have to do that right now as we bootstrap. We can't roll our own steel yet, but that's of course. Oh, okay, the bricks themselves, that's just soil. That's clay soil from on site. So we built our facility off the dirt, literally the dirt and twigs under our feet at our place. So you saw that 4,000 square foot workshop, that was made from the bricks right on the site. And it's working, and we're going to show that we can get ridiculously low costs of building the entire infrastructures. The labor, if we do the labor ourselves, we can, and do it very effectively. You're talking about very, very low costs to the tune of like $3 a square foot for natural building. And we use double brick walls with hammer milled straw insulation in between. So it's super high R value, all from natural local materials. On the roof, for example, we just use commercial roofing, but in between we have a foot of straw, hammer milled straw to keep it warm. So using as much of the natural resources as possible from the land. And we just got our sawmill up and running, so we're going to be able to generate our own lumber. Down the road, the deeper levels of technology mean that you can melt steel, induction furnace is part of it, and you can roll it to things like rebar and metal. So you're talking about building entire one of those tractors at about $500 as opposed to $50,000. So that's the way we're going, and we're not there yet. Don't get too excited, but I think we'll be there. The plan right now is to build our infrastructure and the whole collaborative process through 2013, 2014, and 15, rapid rollout of the set. So by 2015, I hope to be sitting here saying, yeah, we got that tractor for $500. All we needed is rubber for O-rings and things like that, which we can't produce yet ourselves. Though dandelions produce root resin, which can be turned into rubber. So you can see all these crazy things that can happen right off local resources. Bioplastics from plants. You can make your greenhouse glazing. So there's the glazing issue for your homes. So a lot of, I mean, the whole industrial economy, it's literally your rocks, soil, plants, sunlight, water. It's that simple. But you have to be able to have all the information flows to be able to process, to go through those industrial processes on a super low scale. Like we're simply reducing the scale at which this can be done. Back to the brick press, 4 days, and we had a lot of mess ups there. I mean, we didn't really have a well-defined quality control procedure, so some parts just didn't work. We had to redo them. But now, in the next run, we're going to have the full, in addition to the tree, the fabrication diagram tree, we're going to have a full quality control checklist, maybe put it even right on the tree as an overlay or something like that, where you say, okay, well, does this, is this perfectly even? You know, things like that. Is this 2 inches off the edge? Stuff like that, just basics, which are simple if you know what you're looking for, but without that, you'd easily mess it up, so things like that. So how do we get to the 1 day? Our next goal for actually the 22nd and 23rd and 24th, we're getting the second production run, the collaborative production run. Gets interesting, the social model. We're actually inviting the guy who bought the machine. So this guy paid $9,000, and he paid us for that machine. We invited him. So he and a mechanical engineer student and his partner are coming. They're builders in Washington, D.C. area, in some of the richest counties in this country, and they're helping us build the machine. So there's going to be 9 people on this build, 3 of them, at least 6 of us right now. So we're having them pay us to do the work for us. It's great. It's collaborative production. But we're going to optimize some things in this run. So one is the quality control checklist. The second thing is we're developing a CNC torch table, a computer-controlled torch table, which can basically cut out all the metal. You put on one big sheet of metal, like a 4x8 sheet of steel, and this thing will cut out all your parts, and that drastically reduces your time. So a combination of this is called digital fabrication. That's where computer control can allow you to do this stuff in rapid time scales. And with that, we definitely hope for 2 days on this production run, and then see how that works, and after that get it to 1 day. But I can tell you this, we know that one machine takes about 50 hours to build. So if you're talking about 8 people for an 8-hour day, that counts up to 64 hours. So 8 people should definitely be able to do this in 1 day. So we're examining the ergonomics very carefully. We're looking at the numbers. You know, we've got experience. We know what some of these parts take. And we're also redesigning it for modularity. So a lot of the parts are now kind of screw-on, bolt-on, like the supports for the big hopper. You can take off a bolt and take them right off. Like the roller guides for the drawer that moves in and out to load the soil. You just put those on their independent modules. All the hydraulic power is quick connect, so you're literally just connecting hoses to connect to power, like in our power cubes. So that's our hydraulic power unit. It's basically this plug-and-play Lego set of technology that we're building. And that efficiency really does come from interchanging the parts. And we're going one step further. Like right now, I'm reapplying for the Shuttleworth Fellowship, which is a fellowship that supports open source projects. And I'm going to pitch to them for this round that we're taking the modularity to the next level. Like right now, we already use a modular power unit, a power unit that you can use to power your brick machine, a sawmill, your tractor, micro tractor, anything, some of the machining tools. You can power all that through this one device that you plug and play, quick connect with hoses. This is hydraulic power, hydraulic fluid power. We're going to take it to the next level by designing. What we found out is that it takes about 13 distinct modules to build about 30 of the different machines. There's 50 machines total. But if you break it down into a pattern language, like well, what are really the components underneath all this stuff? You find there's an even smaller, there's a finite set, like 13 different items that are used to make up all of these machines. So if we develop just those 13 items and pay attention how we connect them together, then you literally have built those 30 machines. So that's the next level. We're pushing some real limits on this modular, hyper-modular design. It prevents you from having to spend lots of money going to the repairman, and then you're talking about long delay times. You know, if you're in agriculture, you need if you're in harvest season, you need that day. Maybe a rain is coming tomorrow. You can't afford to take it to repair where it takes you a few days. So when the user can service it, you're talking about huge increase in efficiency, cost reduction for the user, And that's how things should be, but we've gotten away from that completely. I mean, our industrial system is in fact doing the opposite, doing design for obsolescence. That's a crime against humanity here. I mean, you're designing things to break after a certain time. I mean, that's a form of slavery in a subtle way. So we're addressing this. We're saying simply, we're going to make technology relevant to people. We're going to make it people-centered technology so that everybody wins. And it's going to be a matter of time, as I said before, the companies have to notice that the point was about serving people. It's about making good products, and we're going to be real contenders for them. We aim to produce real things that really work, and that's why we're confident that this will be could well be the next economy here. So simply, I mean, in a nutshell, it's about making the economy efficient. I would say that in general, business is becoming efficient. They're internalizing things, there's social responsibility, there's environmental issues and global warming and all that that's starting to influence companies. They're just becoming more and more efficient and actually good for the world. Not all of them, but in general, people are moving in a good direction. And there's that huge power of efficiency, simply that in the limit of efficiency, when you eliminate all the competitive waste, all forms of waste, that by definition is open source. You're providing all your designs, you're letting people collaborate, you're reducing cost of development. I cannot see it but defaulting to an open source kind of a pattern in general. So that's my hope that I'm working on, and it seems realistic right now. So, okay, so how about some of the other issues about how to collaborate? So I've heard the thread of schools. There's definite opportunity for technical schools or high schools. Take on projects of design. I mean, we've got tons of design work to do on all these machines. I don't know if there's any specific contacts we can generate from this room regarding technical schools or the school audience here regarding take on a project for a class, or a semester project. And that works best actually if there's a long-term stakeholder at the school, so that this person says, okay, class, you're going to do this project. We promote that you do this open source ecology design. That works best because the stakeholder, like the professor or someone, they're there for a long time, so the program is not going to disappear when a student leaves. So typically, the way it works is you have to have a long-term stakeholder at whatever school you're at. We're starting a discussion with one person at MIT who's got access to some of the mechanical engineering classes. So that's one contact that we're currently following up on. But other than that, no specific things. It really takes, like, what I would encourage, like, what if you guys maybe try to, well, get involved in that, and because it requires a lot of legwork. You have to, I mean, I bet you there's a number of schools out there that right now would be quite willing to do it. For example, there's a person from ITT in Springfield, Missouri, where they're getting their whole class to design, to actually do the CAD for some of our machines. So that's an excellent thing. And if we could have more of that, we could basically get the design, get the fabrication drawings and all of that in a rapid time scale, just using crowd contributions with the university or other school collaborations. So if anybody wants to talk to me about that, if you maybe want to do the work of actually following up, proposing the projects, saying, okay, here's the designs that are active right now. We need CAD drawings, fabrication drawings, or the fabrication diagrams. Someone who's got the full fabrication drawings, they can look at them and say, okay, this is how you do it. They could draw this fabrication diagram. That's one good point of collaboration. That takes a lot of time because you got to go through all these parts. This thing becomes this whole tree, this whole mess, but it really, really works. Like when you can see it on one page, how this whole machine comes together, we found that's extremely effective. And I was actually quite surprised how positive the people were. Like components were coming left and right from all the people that were working. And it was just really encouraging. Morale in the team was up. It's a good method. And okay, so here's another direct invitation. So for the 23rd and 24th, does anyone want to come down to our place and participate in a collaborative production run? That's open. We're actually introducing that option. We're inviting people. We're starting to invite people. We're in the Kansas City area of Missouri. So it's Missouri. But that's an open invitation. So if anyone wants to follow up on that or knows anybody. And that, sorry? This is coming November 23rd, right after Thanksgiving, 23rd and 24th. I think that's Friday and Saturday.
What CAD software do you use?
We use whatever we can get our hands on. It depends on, I mean, that's a real issue because there's no real open source professional level CAD package which allows you to do full fabrication drawings just from your 3D design. We are migrating towards SketchUp because that's simply universally accessible. Yep. And the way it works, we found actually that a single person, a professional engineer on a proprietary package like SolidWorks or something, it's actually not as effective as if you get like 10 people who can do little bits of a SketchUp drawing, or 10 or 100 people. There's so many more people that have access to SketchUp. We're finding that it actually works better to use the lower brow tools where even if you have to do the fabrication drawings manually, it's way faster. We found that for these engineers, it still takes like a month or 2 months to generate these things. And it's about this access barriers. When we found it's simply more effective when there's more people, even if they have lower power tools. It works better that way. For now, we've experimented a bit. There's this procedure that I can count about 120 steps for how you would go from zero to finish of a product. Someone looks at it and they're like, what the hell is that? So it's too complicated. We're trying to reduce it down to about 20 critical steps, create a simple platform around that. So just even a wiki, where if you can have a page for the machine where you just make sure you go through documenting those, say, 20 steps. That's a first step. Once we see that it really works, we can try scaling that, creating more dedicated platforms. Just code that up, whatever, Drupal or WordPress or whatever, some dedicated programming to make it happen. There's local motors, for example. That's somewhat of an open source project that they do collaborative, they do builds of actual cars. They have a nice looking platform. That's one thing to check out. I mean, it's pretty flashy, but it doesn't really allow you all this technical level of development. There's pieces missing. So to do it right is a serious business. And right now primarily what we're doing, we're using the wiki. We're embedding a lot of spreadsheets and conceptual drawings on just simple Google Drawings. We're just using SketchUp quite a bit, just embedding that all in a wiki page, and you can get a lot of that documented that way. But it's far from what the full procedure would look like. Now, regarding the IP issues, I think it's better than what most people think, because as long as you publish it, you're pretty good. So we're publishing everything on Creative Commons, attribution, share alike. We're actually forcing people to share. I thought we could go like, well, just, I don't want to force anybody to do anything. Just if they want to keep it, they should. But no, I think we got to do a little bit of coercion in this game, and that is for you to share. I think that's actually ethical, that we're saying, okay, well, if you took all this stuff that we spent years on, just contribute back to, because you built on it. So I think that's quite ethical to enforce that without being fascist about it or something. But the issue on IP, I think the answer is, as long as you publish, a lot of times you're pretty much safe, because nobody can say that and go to the patent troll, can't just take that and say, oh, I published that first. No, there's a paper trail. Just the date on a wiki document shows that you've got your prior art. If it's published, it's safe. The only question is what happens to derivative work. And a derivative work, if someone wants to, I mean, the license officially says you're required to share this because it's published on a share-alike license. So we could actually pull out the guns and say, okay, there's Creative Commons. They do have a legal enforcement capacity, and they could actually pursue people saying, hey, that's an open project. You can't just close it up. So that's a thing that can happen. But in general, as long as you publish, you're good. I think the trouble comes from people who are just keeping their own secrets, and then someone steals it from them, and they have no paper trail, and they're gone. So that's when it's bad. But as long as you publish, as long as you're transparent, the radical transparency is the saving force here in this game. And so far, we haven't had troubles with it yet. I mean, I expect we might have troubles as our products get really good and people want to copy it. But we say, hey, if you're John Deere, if you're someone you want to copy it, go ahead. Hey, it's good for the world. you're open to do it. We're going to go along our way too. We're going to keep developing stuff. We're going to keep publishing it. We always have a large following, so we're not afraid that we're going to die off. We're running on social capital. We're running on ethics and the values that we carry as the thing that gets us our value. And people respond to that. Okay, so solar panels are high-tech, that's semiconductor technology. For now, we're doing open source solar concentrator electric power. And there's actually a project that used to be open source. It's called SolarFire that's got a good design. But you can do a modern steam engine, which is part of the Global Village construction set, and a solar concentrator to generate power. And we're thinking we can do some breakthrough cost performance on that. So we're going to try to collaborate on that. That's a definite hot area of collaboration, and that's a project, no pun intended, but it's to me, it's like people are, once again, this scarcity myth. I don't believe it. The Earth gets like 10,000 times more power, I mean, you know the figures probably, in one day. Yeah, from the sun, then, or like every day the amount of power is 10,000 times more than we use in an entire year. There's ridiculous figures of, so just imagine if you tapped a little portion of that simply by making the solar concentrator cost effective. That's all it is. It's like you got to drive the cost down so it's actually economically feasible. I believe that open source has that critical component of doing all that research and getting the design so perfect that you're going to be just much cheaper than the competition, the standard companies out there. And if you look at material costs, there's absolutely no limits on material costs because mirrors are about $1 a square foot, or $1.50, depending on what you do. But not if we make our own mirrors. So the point is, there's absolutely no limits based on just material or fabrication considerations why you couldn't do it dirt cheap. So that's the kind of logic we have in all of our thinking. Yes, it is possible. If you had the panels at $1.50 a square foot, just do some basic calculations. I mean, I encourage you to do this, and then when someone says it can't be done, you say, no, it can be done. Just calculate the amount of square footage you would need to get a certain amount of wattage, like a kilowatt, for your house, and how much area of solar concentrator it would require. The figures are simply 1,000 watts per square meter. We know that these systems are 10% efficient. Some of them are 20 or 30% efficient. Well, that means you would only need 10 square meters to power the 1 kilowatt. Now you got to divide it by 4 because of night and seasonality, but the figures end up working out. And I encourage you to go through this basic level of numeracy. If you make the array twice as large, but it's twice as inexpensive, it absolutely works out. That's the bottom line. You kind of got to look at the bottom line there. And I guess it's counterintuitive until you maybe think about it. You're thinking, oh, well, it's twice as little sunlight here, it'll never work. Well, no, you have to go back to the logic behind that. So a brick press, you can build one for about $3,000 to $4,000 in materials. If we build it for somebody and have very efficient labor, like say 40 hours or 50 hours at $50 for a professional fabricator, or even $20. I mean, the fabricators get $20 or something like that. You're talking about 50 hours times $20. It's like $1,000 to produce that if you're really good. Well, if we're selling it at 9,000, yeah, we can count labor costs. Now the model becomes different when you're actually owning the enterprise and you're selling it. You're capturing the value of your own labor. So those economics work out. I mean, there's possibilities. Like for example, right now we can go to our fabricator and say, hey, here's a copy of our Civilization Starter Kit DVD. Make me one of these machines, and we can actually have him build it, and we can sell it or market it somehow collaboratively. But there's actually a business model in here that works, that you can take the DVDs, you can get your local fabricator to build it, and you can sell it, and you can probably make money. In the limit of communities that become autonomous or build in an entire productive economy, you're going to know everybody in your community. It's basically like returning kind of to the village scale, the Dunbar's number scale. You don't need marketing at that point. Marketing is only for like when you've got these massive global megaliths that don't care about anything and are absolutely irresponsible, and they need to push product on you. The first question that happens in the new economy is, what's meaningful product? Do you need hamburgers or local organic agriculture? Things like that, or like 100-mile-per-gallon cars or SUVs. Things, it's how it works. The meaning comes out. This whole thing about higher purpose, it's really promoted by the open source economy concepts that people start thinking about, what's really meaningful? It's like, after we got all the material wealth, I came to the States, it's all the material wealth is there, it's like, what's next? Well, the next thing is meaning. It's like freedom, mastery, purpose, all that kind of stuff starts to emerge. So I have hope for that. The question is that it's less expensive. So I've gone through some numbers on that. And,
I was just wondering if you started looking into it.
Yes, definitely have, because that's a critical argument you have to make, because you can say, well, now if you're making all that yourself, you're spending so much time, it's not cost effective anymore. Just give it to someone who makes 1 billion of them, and they're going to do it cheaper. We're making a claim that's not true. So the calculations go such as we're taking a look at, if you have a 200 kilowatt induction furnace, which is part of the set, so we're scaling the set as the appropriate scale, which would still allow you a productivity level that makes it economically feasible. And I've calculated that the cost of generating your own material over buying it off the shelf would be about 2/3 the cost if we consider all the labor, the energy went into it. So yes, that's being considered, and it looks positive. So basically the real story here is we've got amazing, amazing productive potential that humanity has developed. Companies, when they compete, they're still rather inefficient. They reinventing the wheel all the time. They've got huge budgets for whatever marketing or this or that. It's an example of scale where organization breaks down at a certain scale. So you can reasonably make a claim that if you avoid all that and do it on a very small scale, you can actually get pretty amazing efficiencies. And that's the kind of basic argument that we're showing. The other part is that in the microfactory aspect, with the digital fabrication aspect of the entire set, you've got the capacity to do not only metal melting, but then precision machining. You got CNC machining. You've got up to an industrial robot, laser cutter. So those things now, with those tools, you can build the machines that make the semiconductors. So down the road, we're talking about making our own semiconductors. And the figures are like an acre scale facility using 1990s technology can, well, let's say the facility that would allow you to do these things would be an acre scale facility if we consider 1990s technology. That's a known figure. I've talked about this semiconductor business with somebody who actually knew about it. So the point being, we got our farm back in Missouri, in the middle of nowhere. We can produce up to an advanced civilization at the end of the day.